Hi there. Today we are going to handle the Sherlock and Squares problem. Yeah. So, should I just read, or you guys can pause and read it? Let me go over it briefly. Watson likes to challenge Sherlock's math ability. He'll provide a starting and ending value that describe a range of integers, inclusive of the endpoint. Sherlock must determine the number of square integers within the range. Note: a square integer is an integer which is a square of an integer, e.g. 1, 4, 9, 16, 25, 36, 49, 64, blah blah blah. Okay, so we have an example here. A is equal to 24 and b is equal to 49. There are three square integers in the range, 25, 36, and 49. So we should return 3. Alright, okay, and then we have a sample here and constraint. Alright, so should I just open my replit? Not this. Let me use the up there. Alright, so I'm going to create a new repo. Do I do Python, C, Java, C++? Let's just do Node. Then I'm going to say this Sherlock and Squares. Create repo. Create repo. Create repo. Create repo. Alright, back to the problem. Now let's copy the function so that we don't waste time. Yeah, just paste it there and our code will go right in there. But can we just console dot log and just print our function that you're going to write there and pass in 24 and 49. Yep. Alright, so just to get you guys started and thinking, if you're going to find square integers between two intervals or in a range, the best thing to do is to find the square root of the lower limit and that of the upper limit. Then you just count the integers in between, yeah, because if you go for finding each square root within the range, you're going to do multiple squares within that bracket, yeah. And also calling the square root function will increase your time complexity, yeah. So you understand, yeah. So you don't do that, because you can imagine if someone flashes in a range of maybe 200 million integers in between, that you need to find the individual square roots and check if they're square integers. Yeah, it's going to be a mess. Yeah, so we're going to find the square root of the upper and the lower limits. Yeah, so that's the way that you're going to approach this algorithmically, right? So let's get it done. Yeah, so the first thing that we're going to do here is to check if the limits are indeed upper and lower, because our loop is going to run from the lower integer to the upper integer. We're going to define that here. So the first thing that we need to do is to check if a is actually greater than b, because someone can mess you up right here, right? Someone can give you b as the as the lower integer, and that's going to mess you up. So let's get that down. So if a is greater than b, what we're going to do here, ab is equal to b comma a. Yep, that's pretty straightforward, saying that if a is greater than b, then a becomes our guy b, right? Yeah, you understand that. So let's say again, let lower is equal to math dot square root dot square root of a, right? And we're also going to let upper is equal to math dot square root of b. Yep. Alright, so let me explain this once more. That if you're given 24 and 24 and 49, you want to go checking if 24 is a perfect square, is an integer square root, and then if it's not, you go to 25, you find the square root again, you go 26, you find the square root again, you go 27, you find the square root again. Calling that square root multiple times is going to f you them up. Don't do it. You're going to fail. Alright, so we've already defined our upper and lower limits, but we need to check if the lower limit is an integer. Yeah, if it's included in the range, that is, because for example 24, the square root of 24 is going to be 4.9x, yeah, but 4.9 is not a perfect square, so we're going to discard this damn lower limit. So which means we are going to increment it by 1, yeah. So can we get that one done? All right, so if not number, so I'm not going to use an if statement. I'm still going to use an if statement, but I'm going to use the ternary operator. If you know how to do that, you can just go get it checked. So if not number, so that's if not number, the exclamation mark preceding that negates it, so you have to be careful. Is integer. So if is integer, and then you're going to do the lower limit. Yep, we're checking if that one is an integer. Yep, if it's an integer, then lower limit lower is equal to, we are going to flow this math.flow. We are going to, okay, for example 24 is going to be 4.96, yeah, so we're going to math.flow it back to 4 and then increment 1, yeah, so it's an integer but it's not within the range. You're just going to add 1 on the fly. You get that? Yeah, math.flow lower then plus 1, yeah, just expand these. Yes, and then if not number dot is integer, the upper limits, if it's not an integer, then here what we're going to do, we're just going to flow it as whole because we need the whole integer thing, yeah. So upper is equal to math, come on, what did I just type? Is equal to math dot from, and then we're going to do upper here, and then otherwise here we are not even done with the upper one, so there's something still hanging there if you use a ternary operator. So math.flow upper, yeah, otherwise upper is equal to math.flow upper, this math.flow, just need to flow this upper limit. Am I confusing myself? I doubt. Okay, so this is the first argument, otherwise here, else comes there actually in a ternary operator, else lower is equal to lower. Yep. If it's an integer, you just leave it as an integer and you don't add 1 because it's included in the range. Yeah, it's already an integer. And okay, which means for example, if it's a 25, if the lower limit here was a 25 is going to be included because it's already a square integer. Yeah, so we'll start counting from 5 without necessarily having to increment that. Alright, so that's that. So what we're going to do here is to just loop through and count all the integers within the range. Yeah, so we're going to say let counter is equal to 0, and then here for let I is equal to lower limit. Yep, I is less than or equal to upper, and then we're going to increment I. Yep, what's not going on? And then we are just going to increment the counter plus plus. Alright, so here we are just going to return counter. Yep, let's run this. Boom, 3. There goes our solution. Yeah, so I hope you guys are now understanding this, that okay, we're not going to call a square root from 24 to 49. Yeah, we're just going to find the square root of these numbers and then move from the lowest integer square to the highest integer square, that is if the two limits are included. Is that okay? Yep, so this is our solution. There goes our solution. You can check it on Hackerrank. Let me just replace everything plus the function. There are, yep. So let me run this code, see if it's passing. Yeah, it passes all the test cases, so I can just submit that. Yep, all the test cases, smashing it left and right, success. Alright, that's that, guys. So we're going to handle the next problem. Let me just stop recording.